in the last video, we have looked at creating a Boolean intersection between this larger sphere and this list of smaller spheres. And one thing that we quickly talked about was the fact that we now have multiple pieces of data. In this case, it's these 13 points that then at each of these points create a sphere that is then used as our input to our solid difference. And in this video, I really want to go into how lists in Grasshopper work and give you basically a primer as to how we can use lists and how we can create and view multiple pieces of data. So if you look closely at these two wires that connect these components, you can see that one of them is thinner than the other one. And whenever we have one of these thin wires, this means we have one piece of data. So if we look closely, you can see here one value inherited from one source, and down here you can see that it says 13 values inherited from one source. So the thicker wire is multiple values, and the thin wire is just one value. So how do lists work in Grasshopper? Let me add a panel, and now I want to create multiple pieces of data with this panel, or set multiple pieces of data to this panel. One way I could do this is to simply add multiple number sliders. So let me add a number slider and just add a few more. Make sure they are nice. Maybe set some different values so we have an easier time differentiating between them. And now I want to connect them to this one panel. So instead of having just one value that is shown to me in the panel, I do want to have multiple values. And what you can do in Grasshopper, and what a lot of people show you in tutorials, is that you can hit Shift and add multiple pieces of data or multiple outputs to one input. However, I would strongly discourage you from doing that, because it's not obvious what the order of values is here, and it also gets quite confusing as to if we get more specific and we get more complex, we might have multiple kinds of data structures that we are now all piping into one input without any kind of granular control over. So what we should do instead is to use a merge component. And I can simply double click and hit merge. And we can also find this component when we go in the set tab all the way to the right under the tree components until we have the merge component right here. So what the merge component does is to just, whenever you attach multiple pieces of data, it adds another input. So you can simply just very quickly and easily create, add your pieces of data and then add them in the merge component. And you always know what the order is, so you can always clearly see this is the first one, this is the second one, this is the third one, this is the fifth one. Compared to when you're connecting like this, you have no way of quickly seeing, okay, which is the first one in the list and which is the last one in the list. So I would always encourage you to use this merge component instead of adding multiple pieces of data into one output. So I now have these these 4 different values that get combined in this merge component and then displayed in this panel. And you can see different things in the panel. For once, we have the data path here. We will not go into data tree, so this is even more advanced, but we will just keep this video about lists. And you can see our list right here. And each list, or each item in a list, has an index. Indexes in Grasshopper start at 0. Quite a few programming languages do this, almost all of them do this, where the first item in a list is not at index 1, but it's at index 0. And that is incredibly important that you know this. So the second item is not index 2, it's index 1. And you should really get used to that. Sometimes it can be annoying, especially in Grasshopper, because it's not really consistent in the way some labels are attached. For example, on the merge component, you can see that it starts at 1, but D1 is basically index 0. So this is already kind of confusing, but don't let that distract you. The indexes always start at 0. And our first item in a list is always item at index 0. So now we've created a list. And you can see this with the thicker wire that comes out of this merge component right here. And we have multiple ways of interacting with that list and changing that list. For once, I can just take individual pieces or individual values from that list. So I can use the list as my input in a list item component that you can find all the way in the top right, top left in the set tab. And here you have this list item component, and that is super important because this is used to basically iterate through a list and to get specific items from the list, especially the first and the last item, which is something that we need quite often. So I will copy this panel and use the output of my list item component as the input here. And you can see that this is 0.33, which is our first item, because the index, as you can see when you hover over the index input, is at 0. So let me create a number slider that goes from 0 to, let's say, 5. And if we add this here, index 0 is our first value right here. Index number 1 is the second value, 0.558. Index number 2 is the third value, and so on and so forth. However, if we use an item an index that is larger than the length of our list, so for example, index number 4, and as you can see here, we only have a list that goes to index number 3, it starts back at the beginning. So now, if we use this number slider and set it to index number 4, it will basically wrap back around to the first item in the list. And if it's number 5, then it's back to the second item in the list. So this is something that you should be aware of if you ever select an index that is longer than the list. As long as the wrapping feature is available on a component, it will usually wrap around the list and start from the beginning. We can also go in the other direction. So I can also go in basically a negative index. So if I were to say -1, and I can quickly create a panel with the number -1 by adding a quotation mark and then entering -1 into our search bar. And if I use this as the index for our list item, I can then see that we have the last item of our list that gets displayed here. So index -1 is the last item of our list. If I were to say -2, then of course it's the second to last, -3, third to last, and so on and so forth. So this is also something that is quite useful because it makes it very easy for us to get the first and the last item. So if I wanted to take the first item, I can simply say index number 0. And if I wanted to take the last item, no matter how long the list is, I don't need to check how long is the list and take the last, basically the list length and get the last index from there. I can simply say -1 and I will always get the last item on that list. There's also a nice feature on the list item component that actually not everybody knows about, or at least I haven't seen it used that often in Grasshopper scripts that I've been working with. And that is, if you zoom in, you will get these plus signs on the component. And quite a lot of components have this feature. For example, our merge component, you've seen it that it automatically adds another input once the inputs get full. However, you can also manually add and remove inputs from this component. And our list item component actually lets us add outputs. So we don't even need to specifically set, for example, -1 or +1. If we just want to have the first and the last value, we could, for example, do it like this. And so I is our item at index number 0, and -1 is the item at index 0 - 1, which is the last item. So this is the first item of our list, 0.33, And this is our last item of the list. And yeah, this is basically the basics of using lists and of interacting with lists. There's, of course, a whole lot more. I will show you a few ways of creating lists right now that might come in handy when we're coming back to geometry, because right now we're just working with numbers. One of which is the series component. So what this does is we have a series, which will be a series of numbers with a starting value. In this case, it starts at 0, a step value, which is 1, and a count value, which is 10. So it will create 10 values starting at 0 with a step size of 1. And yeah, don't let it confuse you that the values are listed twice. The left one is still the index, and the right one is the actual value that we have. And if we were to change our step size, for example, so let me take a step size of 2. You can see we start at 0, and the next value is 2, 4, 6, 8. You can see the index, of course, stays the same, and our actual value changes and adapts. So, and we can also, of course, change the count. So instead of 10 values, we could also say, let's create 20. And here you can see that our list simply gets bigger. And this is, for example, something that could be used to, if we, for example, wanted to move a point not just once but multiple times, we could use the series component to create a list of numbers that are always spaced in the same distance. So let me do this as a demonstration. I will create a vector by using the construct point component. I will not really change these coordinates because I'm fine with having my point at 0, 0, 0. But I want to move this point. This is the point that I want to move. This is the geometry that I want to move. And my motion will be a motion in z. And to do that, I can just use a unit z vector and then have a factor. So the unit vector simply is a vector of length number 1. Let's not get into what exactly that means, but all we are interested in is to basically change that vector and to have multiple values right here. So we use our series, our 20 values, as our factor. This creates 20 vectors. And if we use these as our input to our motion in the move command, you can see that we now created 20 points, and each one at the, basically at 0, then at 2, at 4, at 6, at 8, because we have a step size of 2. And if we add another panel and look at this, we can see our list of points where each point, the first one is 0, the second one is at z value 2, and so on and so forth. So we have created a small system that simply allows us to make multiple changes to the same piece of geometry. In this case, it's this point at 0, 0, 0, and this point is moved 20 times by creating 20 vectors from a series of numbers. One last thing. We have only looked at lists right now, and I've already hinted at this value that you see in the top right corner of a panel, which basically shows the branch, which shows a tree structure. In Grasshopper, we can't just have a list of values, we can also have lists of lists. So we have nested lists where basically, we have a list and then we have 20 lists within that list. And this gets confusing quite quickly. And I don't want to get into this right now, but if you stumble upon this when you just try things out, if I were, for example, to graft this right here, we would now have a list of lists. Each of these lists only has one value, so it's not as confusing. But you will see that the wire between components becomes this dotted, thicker wire. And this always means we have a tree structure. Without explaining what exactly this is, if you stumble upon it, for now, we can mostly just flatten the list by right-clicking on an output and selecting the flatten option, and then we always just have one list of values. So if you ever get to the point where you have this data tree and you might not want it, you can simply flatten the output to make sure that that you have one list that is much easier to work with. But of course, sometimes you need to know, you need multiple lists because you want to maybe do something different with each list. So yeah, we'll get to that in a later video. For now, we will mostly work with flattened lists.